In the bitter cold of December 2021, a new eye opened in the heavens. 20 years late and $10 billion over budget, the James Webb Space Telescope unfolded its golden hexagonal mirrors like a mechanical flower blooming in the darkness, positioning itself a million miles from Earth at a place where gravity holds still. It was designed to see the first stars igniting after the Big Bang, to peer through cosmic dust at galaxies forming when the universe was young, to capture light that had been traveling for 13 billion years. Nobody expected it to turn that gaze inward, back toward our own solar system, and find something at the edge of our planetary family that simply should not exist. But in the summer of 2024, that is exactly what happened. James Webb pointed its infrared sensors at Pluto, the dwarf planet demoted by controversy in 2006. And what it saw broke the rules we thought governed the outer solar system. For nearly a century, Pluto was the ninth planet, a tiny frozen world discovered by Clyde Tombaugh in 1930 through painstaking comparison of photographic plates. It was a dot, a smudge, a mystery so distant that even the mighty Hubble Space Telescope could only resolve it into a blurry, pixelated sphere with vague patches of light and dark. When NASA's New Horizons spacecraft flew past Pluto in 2015, it transformed that smudge into a breathtaking world of nitrogen glaciers, water ice mountains as tall as the Rockies, and a heart-shaped plain called Tombaugh Regio that became instantly iconic. But New Horizons was a brief encounter, a single snapshot during a high-speed flyby that lasted only hours. It gave us a face, not a life story. It could not watch Pluto change. It could not see what happened when the dwarf planet turned its seasons. And it certainly could not explain why Pluto was still geologically active when it should have been frozen solid for billions of years. James Webb was not built for Pluto. Its instruments were calibrated for infrared light from the edge of time, not for a relatively nearby ice ball reflecting a dim fraction of the sun's feeble glow at 5 billion kilometers away. The telescope's planners never imagined using their billion-dollar creation to study a world smaller than Earth's moon. But scientists are curious creatures, and when you build the most powerful telescope in human history, someone will eventually point it at everything. What Webb revealed when it focused on Pluto was not just sharper images. It was atmospheric data that made no sense. It was chemical signatures of complex molecules forming in a place too cold for such chemistry to occur. It was evidence that Pluto's thin envelope of nitrogen, methane, and carbon monoxide was not only still present, but actively changing, thickening in ways that defied the established models of atmospheric escape in deep space. The problem is simple, but devastating to our assumptions. Pluto is small. It is far from the sun. Its surface temperature hovers around minus 230 degrees Celsius, cold enough to freeze nitrogen into solid ice. Any atmosphere it possesses should be barely there, a wisp of gas, barely clinging to a world with weak gravity, constantly bleeding into space because Pluto cannot hold it. Over billions of years, that atmosphere should have vanished entirely, leaving behind nothing but a bare, dead rock. Yet, Webb detected something else. It found that Pluto's atmosphere is not bleeding away as predicted. It is being replenished. Something on or inside that frozen world is actively pumping fresh material into the sky. And that process should be impossible, given the amount of energy Pluto receives from the sun. The math does not work. The physics rebels. And the implications ripple outward through everything we thought we knew about planetary science. To understand why this matters, you have to remember what Pluto represents in the human story. It was the last planet discovered by an American, found during the Great Depression by a self-taught farm boy from Kansas, who built his own telescopes and spent months in an unheated observatory dome, comparing photographic plates by eye. Tombaugh's discovery gave a struggling nation something to marvel at, a new world at the frontier. Then, in 2006, the International Astronomical Union stripped Pluto of its planetary status, reclassifying it as a dwarf planet, and sparking a cultural debate that continues today. Textbooks were rewritten, mnemonics were adjusted. Children learned that there were 8 planets, not 9. But the science behind that decision was always shaky, based on orbital dynamics and clearing neighborhoods, rather than on what Pluto actually is. James Webb is now showing us that Pluto is far more complex than the committee that demoted it ever imagined. The telescope's infrared vision peered through Pluto's atmosphere and detected thermal patterns on the surface that suggest internal heat. Not much, but enough. Enough to keep a subsurface ocean liquid. Enough to drive cryovolcanism, where water and ammonia erupt through cracks in the ice instead of molten rock. Enough to make Pluto a living world, rather than a dead one. And here is where the story becomes truly uncomfortable for planetary scientists. If Pluto, tiny and distant and starved of solar energy, can maintain internal heat and geological activity, then how many other small worlds are doing the same? The Kuiper belt, that ring of icy debris beyond Neptune where Pluto resides, contains thousands of similar objects. Eris, Makemake, Haumea, Sedna, and countless others we have not even named yet. If Pluto is alive, they might be too. Our solar system could be filled with hidden oceans, with chemistry taking place in darkness, with conditions that might, under some definitions we do not yet understand, be considered habitable. The New Horizons mission gave us a photograph. James Webb is giving us a diagnosis, and the patient is not dying. The data coming back from Webb's near-infrared camera and its spectrographs shows seasonal changes in Pluto's atmosphere that cycle over decades, driven not by the faint warmth of the sun, but by internal processes we are only beginning to guess at. Methane frost migrates across the surface. Nitrogen ice flows like glaciers. The heart-shaped plane pulses with activity. And beneath it all, something warm enough to keep water liquid may be waiting, sealed away from the void by hundreds of kilometers of frozen shell. This is not the Pluto we were taught in school. This is not the static, irrelevant rock at the edge of the solar system that textbooks described. This is a world with weather, with geology, with chemistry, and perhaps with the ingredients that elsewhere in the cosmos have led to life. What James Webb found should not be possible, because our models of small worlds were too simple. We assumed that size and distance from the sun were the only variables that mattered. We assumed that without tidal heating from a giant planet, small worlds freeze solid and die. Pluto is proving both assumptions wrong. It carries its own heat source, likely from radioactive decay in its rocky core, and from the slow release of gravitational energy accumulated during its formation. Combined with a thick insulating shell of ice, that modest warmth is enough to maintain a hidden ocean for 4.5 billion years. That means Pluto has been warm and wet beneath its frozen face for as long as life has existed on Earth. The philosophical weight of that realization is staggering. The conditions for chemistry, and perhaps for biology, have existed in our own backyard for the entire history of life on our planet, and we only just noticed. As the data continues to flow back from that million-mile perch, scientists are scrambling to rewrite the textbooks they rewrote in 2006. Missions are being proposed to return to Pluto, this time to orbit rather than fly past, to land, to drill, to sample the ice and search for the organic molecules that Webb's spectrographs are hinting at. The dwarf planet has become a destination again, not a footnote, and the telescope that was built to look backward in time toward the birth of the universe has instead reminded us that we do not even fully understand our own neighborhood. The impossible is not always a violation of nature. Sometimes it is a violation of our assumptions. Pluto was supposed to be dead. Instead, it is whispering that the outer solar system is alive, complex, and stranger than we dared to believe. And if a world this small and this cold can surprise us, then the universe has barely begun to reveal its secrets.